Hi class, this video is over section 3.2. We will have two parts to this video. This is part 1, where we will be able to use properties of concurrent lines and triangles. The second part of the video will deal with medians and altitudes. So first, let's draw an angle bisector and a perpendicular bisector in this triangle. So an angle bisector just has to cut one of the angles in half. So I'm drawing an angle bisector, and I need to show that those two angles are congruent. Now a perpendicular bisector has to be perpendicular to one of the sides and cut the side in half. It has nothing to do with an angle. So let's cut the bottom side in half, and it has to be perpendicular to the bottom side. Now for some new vocab. When three or more lines intersect in a point, the lines are called concurrent. The point at which concurrent lines meet is the point of concurrency. Here's our first theorem. The perpendicular bisectors of the three sides of a triangle are concurrent at a point that is equidistant from the triangle's three vertices. This point is called the circumcenter. So what this is saying is if you drew in the three perpendicular bisectors on a triangle, so if you drew the line which cuts each side in half and is perpendicular to each side, they would all meet at a point, and this point is going to be equal distance from each of the vertices. So here's our triangle. We're going to draw in our three perpendicular bisectors, and you can see that they meet at this point right here. This point is actually equidistant from every vertex, no matter what kind of triangle that you draw. So example 1, find the values of x and y. So we can see that x is on one of the sides. I'm telling you that this is a perpendicular bisector, which means it's cutting this side in half. So that means that these two pieces have to be congruent, which means we can set them equal to find x. So x is going to be 11. Now y is coming from the point of concurrency. This is three perpendicular bisectors meeting here, which means that these lines going to the vertex are equal. So we're going to set those equal to get that y is equal to 7. Here's another theorem, another way to see the theorem out of your book. Remember that this point is called the circumcenter. So the perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant from the vertices of the triangle. So all these blue lines are going to be equal distance. Next theorem. The angle bisectors of a triangle are concurrent at a point that is equidistant from the triangle's three sides. This point is called the incenter. So here we have a triangle, and we are going to draw in our three angle bisectors. So this point where they all meet is called the incenter, and is going to be equidistant from each of the sides of the triangle. Find the value of y. So we can see that our angle bisectors are meeting in our incenter, and this incenter is going to be equidistant from the sides of the triangle. So that means I need to set those two equal to get that y is equal to 18. Remember, whenever you're finding distance to a side, you need to make sure it's the perpendicular distance. That's why we didn't just use these lines right here. We drew in new lines, and these are going to be perpendicular. You can see it better in this picture here. So here are my angle bisectors. You can see it's cutting each of the angles in half, and they're meeting at this point right here called the incenter. So that means that DP, EP, and FP are all going to be equal distance from each of the sides. Notice that the distance is perpendicular. Alright, so a quick review and summary of what we just talked about. If the sides are bisected, as in a perpendicular bisector, the point of concurrency is going to be equidistant from the triangle's vertices. If the angles are bisected, as in angle bisectors, the point of concurrency is equidistant from the triangle's sides. So it's kind of opposite of what's happening. If the sides are bisected, it's equidistant from the vertices. If the angles are bisected, then it's equidistant from the sides. So let's do some more practice using this. Find the value of x if km is equal to x and kj is equal to 2x minus 5. So here we can see we have angle bisectors. We're going to cut each of these angles in half. Now we need to draw in kj and km because they're not currently on this picture. So we're going to draw those two lines in. Since the angles are being bisected, I know that this is going to be equidistant from the sides. So that means I'm going to set those two values equal. Km was equal to x and kj was equal to 2x minus 5. I solve my equation to get that x is equal to 5. What is the length of kp? So kp is another distance going from here to the side, which means it's going to be the same as the other two, so it's also going to be 5. Next one, find the value of x if AG is equal to 2x minus 2 and GC is equal to x plus 10. So here I have perpendicular bisectors. I know it's not being shown, but I'm telling you, they're perpendicular bisectors. So AG would be the distance from this point of concurrency to the angle, and GC would be the point from the point of concurrency to angle C. So we need to draw in those lines, and we know that these lines are going to be equidistant from each other, so we're going to set them equal and solve to get that x is equal to 12. What is the length of BG? So BG is the last line that's going from the point of concurrency to angle B, so it's going to be the same as the other two. So let's find the measure of the other two. If I plug in x, I would get 22 for GC. If I plug in x here, I'd also get 22 for GC. 24 minus 2 is 22. So that means that BG is going to be 22. I'm going to start a new video for the second half of this lesson. So please make sure that you watch 5.2 part 2 directly after watching this one.